Hey guys, Professor Falcucci here. Sorry I missed class yesterday, but I do want to go over these problems that I posted for you. I hope at this point all of you have had a chance to do them. Um, After we go over these, if you have additional questions, feel free to ask me in class on Tuesday or reach out to me via email. But just a reminder, at the end of class on Tuesday, your Chapter 9 quiz will be posted. So if we look at the first prompt right here, the average points allowed by defense in the NFL last season were 22.3 points. Assume it followed a normal distribution and had a standard deviation of 9.9 points. In 16 games, the Patriots only allowed 4.1 points, 14.1 points using the critical value approach at a 5% significance level. Does this provide evidence the Patriots' average points per game was different than the entire league? So a couple things here, okay? We're told it's normally distributed, which is good. Okay, we're also told the population standard deviation, meaning this is going to be a z-test. So right there, right, we have our population standard deviation right there. So this is going to be a z-test. But still, step one, we're going to write our hypotheses. So, okay, our null hypothesis, mu is equal to 22.3. Our alternative hypothesis, okay, mu, and here it says, does this provide evidence the Patriots' points per game was different? So it could be greater than, it could be less than, so we're going to go with not equal to 22.3. So this is going to be a two-tailed test, okay? Step two, we're going to list our alpha level, which is given to us here. Our significance level is 0.05. Now, step three, okay, we're going to find like our test statistic here. So z is equal to my sample mean minus the population mean over my standard deviation. And in this case, it's going to be over the population standard deviation divided by the square root of n. So if I plug everything in here, 14.1 minus 22.3 over my population standard deviation, which is 9.9, divided by the square root of my sample size, which is 16. So I'm going to do that in my calculator here. And I get a z-score that's equal to negative 3.31. All right, so my z-score here, negative 3.31. Now, on step 4 here, I need to find out what is my critical value. And hopefully you remember last class or a couple of classes ago, I gave you all of the important critical values for us to know. So, okay, a two-tailed test right here, right? This is a two-tailed test, okay? So it's going to be plus, and it's at an alpha level of 0.05, so it's going to be plus or minus 1.96. So my critical value here is going to be plus or minus 1.96. Now, step 5, I need to figure out, am I going to reject the hypothesis, the null hypothesis, or not? All right, so in how we use the critical values, all right, if I just sketch a normal model right here, all right, and I know, right, and I label my critical value here, so I have negative 1.96 would be about right there, positive 1.96 would be about there, okay? So, okay, whenever values get outside of our critical values, okay, whenever our test statistic gets outside of our critical values, that's when we would reject. Meaning, if our test statistic is less than negative 1.96, or if our test statistic is greater than 1.96, that is when I will reject. For the two-tailed test here, if it's contained within that range right there, we would do not reject. All right, and I know right here, right, our test statistic, okay, is negative 3.31, so that's going to be somewhere way down right here, meaning I'm going to reject the null hypothesis. Okay, so the critical values. If it's a left-tailed test or we're talking about an alternative hypothesis that's less than, it's when it's below the critical value. If it's a right-tailed test, or we're talking about an alternative hypothesis that's greater than, we reject if it's greater than that critical value. Okay, if it's a two-tailed test like we have here, okay, we're looking, is it outside of that range right there from negative 1.96 to positive 1.96? So here we would reject. And now we are going to write our conclusion. So at a 5% significance level, okay, I reject the null hypothesis. Okay, if I'm rejecting the null hypothesis, that means the data do provide evidence. So here, the data do provide evidence to suggest, okay, the Patriots' average points per game did differ from the 22.3, okay, average of the NFL. Okay, so we're saying there is enough evidence to suggest that it was in fact different. Okay, if I was going to do this out on the calculator instead, okay, if I pop up my calculator here and just move it over a little bit here so we can see it. Okay, so we're going to the stat menu. We're going over to tests. We said this was a z-test. Okay, so if we go over, we're going to enter our stats. So we said our mean was 22.3. Our population standard deviation was 9.9. I got to go back up here and make sure it's over on stats. Enter. Okay, our sample that we got was 14.1. It was 16 was the sample size. We're talking about not equal. So we'd go down here and hit calculate. Okay, and you see we get the same z-score of negative 3.31, all right, which we would compare to the critical value of plus or minus 1.96 that we found. On prompt number 2 right here. All right, during our current lockdown, a study has shown that families get an average of 7.9 arguments per day. The population is normally distributed. After taking a random sample of 11 days, okay, my family gets into an average of 9.1 arguments per day with a standard deviation of 2.4. At a 10% significance level, do the data show that my family gets in more arguments than the 7.9 suggested by the study? Use the critical value approach. So again, okay, we're using a critical value approach here, but the key difference with this prompt compared to the last prompt, okay, I don't know the population, the standard deviation of the population. Okay, this standard deviation that I have right here is related to the sample. Okay, meaning, okay, this is going to be a t-test. But starting out right here, I mean, everything's going to be different, okay, except we're calculating a t statistic versus a z statistic. So step 1, we're going to be the same. Our null and our alternative hypothesis. So our null hypothesis here, mu is equal to the 7.9 that was told to us. Alternative hypothesis, I asked the question more, okay, so it would be mu is greater than 7.9. Step 2, we're going to write down our significance level. Alpha is equal to 0.10. Step 3, we need to calculate our t statistic, right? So t is equal to our sample, right, minus the mean. Now it is our, okay, sample standard deviation divided by the square root of n. So if we're going to do this out right here, right, my sample here is 9.1, my sample mean, minus 7.9. over 2.4 divided by the square root of 11. All right, so if I go ahead and do that on the calculator, okay, I get a t statistic here of 1.66, about 1.658, 1.66, somewhere right about there. All right, on step 4 here, okay, I need to figure out what my critical value is. So if we go to the next slide right here, a couple things. If n, so remember, degrees of freedom is equal to n minus 1 for my t test right here. So for this prompt right here, degrees of freedom said 11 minus 1, I'm going to have 10 degrees of freedom, which means my focus, okay, is on this row right here. 10 degrees of freedom, that is my focus, okay, on that row right there. All right. Now, what's my alpha level I talked about? My alpha level is t is 0.10 right here. So if I go down right here, meaning my test statistic that I am, my critical value is going to be 1.372. Okay, and this is a right-tailed test. I'm talking about greater than, so it is positive. We're going to leave that number positive like it is. If it was a left-tailed test, okay, we would just make that a negative number because everything's symmetrical on our distributions here. So now, if I go back here, I know that my critical value is equal to 1.372. Okay, so now we're going to figure out, are we rejecting or are we not rejecting? So if I sketch my T model right here, which looks basically the same thing as a normal model, right? I got my mean in the middle, and we just said my critical value is 1.372. So because it's a right-tailed test greater than, anything, above that value, I would have to reject. Anything below that value, do not reject. Okay, so if I look at the value I got here, my test statistic here, my t-score was 1.66. All right, so my t-score right there, 1.66. So clearly it's above that value. So again, I'm going to reject, okay, the null hypothesis. And I would word the conclusion exactly the same as if it was a z-test. So we're always wording the conclusions exactly the same. So here, at a 10% significance level, okay, I reject the null hypothesis. I reject the null hypothesis. Okay, the data do provide evidence to suggest, okay, that my family gets in more arguments than the 7.9 that the study claims. All right. Now, again, I could also do this on the calculator as well if I didn't want to do all of this out by hand. Okay, so on the calculator here, if I go to stat, over to tests, now this is going to be a t-test, not a z-test. So I would choose t-test right here. Okay, I'm going to input all my data right here. So my mean that we're talking about was 7.9. That's my population mean I said. My sample mean here I said was 9.1. My sample standard deviation was 2.4. Okay, n, my sample size was 11. All right, I'm talking about this being greater than. So if I scroll down here, I want this to be greater than. Go down here and hit calculate. Okay, and we get our test statistic, our t-statistic and everything right there. Okay, and we are good to go. All right. The t-statistic here, 1.73. So obviously I must have made a mistake on my calculations back there. But you can see, nonetheless, we still end up with rejecting the null hypothesis just like we should. And now if we look at our final example here, okay, the average age of students at Worcester State University is 20.99 with a standard deviation of 4.89. The population is normally distributed. A sample of 19 students from MA150 is taken, and their average age is 18.62. At a 1% significance level, is there enough evidence to suggest on average MA150 students are younger than the 20.99 years of age? Use the p-value approach. Okay, so even though we're using the p-value approach here, we're still starting off the same. Okay, our null hypothesis, mu would be equal to 20.99. Our alternative hypothesis, we want to know younger, so it means that mu would be less than 20.99. My alpha level here now would be 0.01. Step 3, I'm still going to calculate my test statistic. So my z-score here, okay, this is a z-test because we know the population standard deviation. There's my population standard deviation right there. So this is a z-test. So my sample my sample mean, 18.62 minus 20.99 divided by, okay, my population standard deviation, which is 4.89, over the square root of my sample size, okay, and I'm talking about a sample of 19 right here. All right, so if I do this out in the calculator, right, I will get about a z-score here equal to about negative 2.11. Now, step 4 here, what is the p-value to go with that? Okay, so if we're going to do it by hand, right, and we're looking for the p-value to go with that, okay, remember that these areas all measure left, okay, of our point, which is okay here for this scenario because we're talking about less than, okay, left-tailed test. So, I'm looking here, we're talking about negative 2.11. So there's a little snippet of the chart that you guys have. So I'm going down here to negative 2.1, right? So I'm talking about this row right here. It's going to be one of those values right there. And then I'm going up here to its ending point right here. All right, 0.01 is where it ends because it's negative 2.11, meaning this, is the row right there. And clearly right here is where they intersect. Okay, so the p-value we got for this prompt, okay, is 0.0174. So my p-value, 0.0174. Now, okay, for these ones here, it might be easier for you to not draw a picture. Okay, it's up to you. If you want to draw the picture, you can. But the key thing here, okay, is remember on these ones right here, if our p-value, okay, is less than alpha, then we reject the null hypothesis. If the p-value is greater than alpha, then we fail to reject the null hypothesis. So here, right, if I have a p-value, right, my p-value is 0.0174, and my alpha level is 0.01, 0.0174 is greater than 0.01, okay, meaning I am going to fail to reject the null hypothesis. My alpha level is, my p-value is greater than my alpha level. So if the p-value is greater than the alpha level, if we fail to reject. If the p-value is less than the alpha level, then we would reject. And then now we're going to write the conclusions, or the conclusion just how we normally would. At a 1% significance level, okay, I fail to reject the null hypothesis, okay? The data do not provide enough evidence to suggest, okay, MA150 students, okay, average age is less than the 20.99 of all Worcester State University students. Okay, so it does not provide enough evidence, so we fail to reject the null hypothesis. Again, we can do this on the calculator too. So I have my calculator right here. Okay, stat over to tests. We said this is a z-test because we know the population standard deviation. Okay, so my population standard mean is 20.99. My population standard deviation is 4.89. Okay, the mean I got was 18.62. Okay, my sample size was 19. Now we go down here, we're talking about less than. It's a left-tailed test, less than, because we want to know younger. And then we go down here to calculate. Right, and you can see we got the negative 2.11. Okay, just like we got. Our z-score, our p-value is 0.0173, so it's just a little bit off on the calculator in the chart, but essentially the same thing, and we'd reach all of the same conclusions. So I really hope those videos helped you with those prompts, understand everything better. Again, if there's additional questions, feel free to reach out to me via email, or you can ask them in class on Tuesday. But again, like I said, at the end of class on Tuesday, your Chapter 9 quiz will still be assigned. I hope you guys all have a great weekend, and I will see you in class on Tuesday.